the responses are valued. It is always exciting for current students of the school to connect with their alumni who can provide great insights into the courses they are pursuing, the industries they work in, and their personal and professional journeys. Today, we have with us Miss Anjali Manoj. She is an alumnus of CMR PU ITPL and is currently an undergraduate student at the University of Washington, majoring in Earth and Space Sciences, while also pursuing a minor in Environmental Science and Terrestrial Management. She is currently involved in research in paleobotany at the Burke Museum of Natural History and Culture, where she essentially reconstructs the climate and environment present millions of years ago through leaf fossils. She is also the student ambassador for her major. Welcome back to your alma mater, Miss Anjali Manoj. Over to you.
Hi, everyone. I'm going to share my screen right now. All right. Hi, everyone. Good morning. Although right now it's very much nighttime for me here in Seattle. I'm Anjali Manoj, and I'm an undergraduate student at the University of Washington in Seattle. And fun fact, my sister is actually in the audience today, and I don't know if that has to make me more at peace or if I should be more nervous about giving this talk. But let's begin. I'm going to be talking today about how geology isn't just rocks. So here's a question for everybody. What are some ways you think that geology plays a role in your everyday life? What are ways in which you can see how knowledge about the earth, rocks and minerals and etc. are important in our everyday life? One important example that we can see is like the image that I put in this slide, right? Salt. Salt it goes in all our food, and it's an important mineral that we use on almost all the food that we eat, and it's very essential for so many biological processes inside our body and so much more, right? Geology is all around us. There are multiple places where the knowledge of geology is extremely crucial. For example, like some of the ways are energy exploration, right? How do we source energy, not just fossil fuels, geothermal energy, hydro energy, all these energy, like how we source these energy is essentially built on what we know about the earth, what we're able to learn about the earth. Then there's agriculture, the soils that we use that are appropriate for growing different kinds of plants and fruits and vegetables that we eat, right? So it's important to know what kind of soils support what kind of plants, whether this particular land has soil that can support agriculture, and how to make soils and land more suitable for agriculture. That's an important reason, way in which knowing what kind of soil, knowing geology is important, right? And another way is water. We all drink water. Water is an important resource. The world is covered in 75% of water, and water is an important agent of shaping the landform. And so another way is natural disasters, knowing about geology, knowing about how to predict natural disasters, and how to see what the impact of these natural disasters are. All these are ways in which geology is very important to know about. And cell phones, the minerals that go into your toothpaste, so many more ways, right? So then that prompts the questions, what is geology then? Geology, unlike what we tend to think of, right? When most people ask what is geology, they think geology is the study of rocks. But I'm here to tell you that geology is not just the study of rocks. It's the study of the earth, what is beneath it, what is on it, and the processes that shape the earth, right? But it's not just earth that we think about. Earth is just a means for us to study how these processes work, right? But these same processes occur in planets and worlds outside the earth, like in the solar system and beyond. And so knowing about how these processes are carried out on the earth helps us understand what these processes are like on planets and worlds beyond the earth. So geology has a very far reach of what it can do and what the body of knowledge encompasses. Here's a list of some subdisciplines that fall under that come under geology or earth sciences, right? Some of my personal favorites are paleontology, which is the study of life in the past, right? A life millions of years ago. And when most people think about paleontology, they think of Jurassic Park, they think of Ross from Friends. All these are good examples of paleontologists. They're much more better ones, but yeah. The next one is planetary geology. I really enjoy planetary geology, especially about Mars. I still remember in 12th grade, I discovered so many important things about Mars. Like I discovered my love and passion for Mars. And so I went up to Anita ma'am, who was the principal of CMR at that point, and told her that I want to give a presentation on Mars. Please let me give a talk on Mars. And she very kindly allowed me to talk in front of 10 people in the space club at that point of time. And I spoke for like 30 minutes on Mars. So clearly I like planetary geology a lot. And then other important geology subdisciplines that I've come across through my studies so far, through different classes that I've taken so far, is geobiology, which is the impact that life has on the Earth's surface and vice versa, how the Earth's surface impacts life on the Earth. And then there's oceanography, which is under the oceans, what is happening. Here's a fun fact again. Did you know that we know more about the surface of the moon than we do about our own oceans? We have mapped out the surface of the moon almost completely, but we still don't know. We know barely, I want to say, and don't quote me on this, please verify this, but I want to say it's somewhere around less than 10% of the like the ocean surface beneath the ocean has been mapped. So that clearly shows that where work needs to be done, right? And when we're looking at life forms outside the Earth, we're looking at life in planets that are covered by planets and moons that are covered by oceans, right? And if we don't know what's happening in the oceans within our own Earth, how are we going to look for life forms beyond, right? So a lot of cool subdisciplines with a lot of scope for interesting work that can be done within each of these subdisciplines. Now an important question, like a lot of people ask me when I tell them I'm studying geology and I'm an earth and space science major, they ask me, why did you choose geology? What brought you to it? And I want to say that I've always been somebody who has a deep appreciation for the nature and the environment around me, right? I have a deep appreciation for the earth that we live in, the processes and the life forms and everything and how they interact with each other. And in 12th grade, when I was thinking about what I wanted to do, and my options were engineering or doctor, and both of those didn't seem very appealing to me at that point. And so I did some like vigorous Google searching, and I was reading up about different fields that existed and universities that offer courses in those fields, and started looking into what classes there are to see if any of those classes pique my interest in any way. And that's when I realized that I really enjoyed learning about how life has changed through time, how life got to where we are today, how the earth has gotten to where it is today from what it was 4.5 billion years ago, right? And so these photos, that's the first photo of me, is me kayaking at my university's intramural activity center. And the next photo is me on fieldwork with a bunch of PhD students. I will talk about fieldwork in further slides. And that the photo right next to that is of leaf fossils that I was able to collect it as part of my own rock collection. Clearly, I'm a rock nerd. I have a rock collection, but those leaf fossils are 12 to 16 million years old, and I have them at home with me. And the dinosaur bones that you're seeing there is from is photos that I took from the museum that I work at. But I have to let people know also that the reason I fell in love with geology is because I was interested in learning about how things have changed through time, right? Now my interests have shifted a little bit now that I've had the opportunity to take classes in geology, take classes in earth sciences and space sciences, and now I've had a decent amount of exploration within the subdisciplines of geology, right? And I'm increasingly starting to feel that maybe remote sensing, which is using imagery taken by satellites, by aeroplanes, etc., flying over the Earth's surface to like create maps and visual information systems for people to get information about the Earth's surface, right? So I've started to see that remote sensing is probably what I enjoy the most, what I find greatest joy doing. And in fact, these are some of the maps that I have created as part of projects that I've done for classes just 3 months ago for a remote sensing class that I did. And all these hands-on projects are what have made me realize that maybe remote sensing is what I really want to pursue. And while biology and paleontology is what got me into earth sciences, through the course of exploring, I realized that maybe it's something else is what is exciting me more right now. And cool fact, the two pictures at the bottom, the two green photos, that's actually the before and after photo of a volcanic eruption of a volcano that's quite close to Seattle, where I'm currently at. And here's some pictures of fun stuff that I've done so far. As part of ever since I've started my Earth and Space Science degree here at the University of Washington, I started college here in 2019, and it's been a little more than 2 years now. And in just those 2 years, I've been able to go on fieldwork. So I've done fieldwork in Oregon, the state of Oregon, which is the neighboring state just south of us, where I accompanied two PhD students for a whole week. We were collecting leaf fossils in a very fossil-rich site. I got to see not just leaf fossils, I saw fish fossils, I saw mammal fossils, I saw really cool rock formations. It was a very exciting time. And the best part is I got to camp in the middle of nowhere, which was fun. The second photo that I have here is me very happily showing my screen after I finished presenting at a research conference in May 2020, and where I talked about the work that I do with leaf fossils at the museum that I work at, which is the next photo, the Burke Museum. The Burke Museum of Culture and Natural History. That's where I spent a significant amount of time at. And it has, so I work in the paleontology section. I work amongst the big shelves where thousands of dinosaurs and the mammoth fossils and saber-toothed tiger fossils are all like stored behind me. And it's a very wonderful experience that I've had so far. And in this photo right there, that's part of their display. They have a mammoth right next to a giant sloth and then a saber-toothed tiger. What does that remind you of? And then the next photo that I have next to it is from the hikes that I've been able to go on. So this is a photo that I took on a hike that I went on this summer, last summer, to Mount Rainier, which is another volcano right outside of Seattle. It's a dormant volcano, but it's there. They think it might erupt sometime in the near future. And below are a couple more photos from hikes that I've been on, ways I've been able to explore the landscape around me, right? How these big mountains have been formed, how the forests that now are at the foothills of these mountains have shaped through not just centuries, through millions of years, right? What this landscape looked like millions of years ago, what were the life forms here? All these are things that I've been able to explore thanks to the degree, I've been able to explore and appreciate thanks to the classes that I've been taking and the people that I've met. And then I've been able to also attend a bunch of very interesting talks by paleontologists and geologists and planetary geologists, planetary scientists these past few months, unfortunately through Zoom, because that's where everything's been these past few years, but still very informational, and you still learn to make those connections, right? Some fun things that I hope to do this in the upcoming years. In fact, I'm currently in the process of applying to a bunch of internships within remote sensing, because now that I've realized that remote sensing and satellite imagery and planetary sciences are things that I am really interested in. I want to do internships and have internships and research experiences in those fields so that I can get an in-depth experience of what it's like before I commit to it as a career, right? And another thing I'm looking forward to is field camp. Field camp is something that all Earth and space science students have to do. It's part of your degree, and although it's a have to, it's actually something we all look forward to, because it's 6 to 12 weeks. In For our university, we go to Montana and other nearby states where they have really cool geology, really cool landforms over there. So you spend those 6 to 12 weeks in these beautiful landscapes doing practical geological experiments and geological measurements, right? And so similar to these field camps is what a lot of space scientists also use, right? When before they sent astronauts to the moon to collect rock samples, to collect all these different to perform all these different experiments on the moon, what they did is they replicated those experiments on Earth, because the Earth is our primary testing ground for anything that we do elsewhere in the universe. So field camp is a very important part of Earth and space science education, and not just education, even in like professional work. And then I hope to continue to explore more within the subdisciplines of geology. I mean, right now I'm really passionate about remote sensing, but maybe it's something else. Maybe while exploring remote sensing, I find out there's another field of geology that excites me more, and I'll be happy about it. I'll be happy to find out something that I have a deep passion to learn more about, right? So what does the future hold for me? This is something I've had to do a lot of introspecting about these past few weeks, especially now that I'm a third year Earth and space science student, and after my fourth year, I have to graduate and actually go out into the real world. So I've had to do a lot of thinking about what I am going to do, what that something is that I'm going to do once I graduate. And so my immediate goal is to get my degree, become a Bachelor of Science holder in Earth and Space Sciences, and then maybe work for a couple of years. If remote sensing is still my passion, then that's something I definitely want to pursue. And eventually, my long-term goal is to get a PhD and then pursue teaching, maybe at the university level. And like I said, I want to keep continuing to explore, not just in my field, but in the world around me. Now, I think this is the thing that most people who are attending today's talk are curious about. So what is the future of geology? Why study geology? Why become a geologist? What kind of jobs can I get? What is there to do in the field of geology, right? And I think one thing that most people are really excited about is Mars exploration. I was really excited about Mars exploration. I still am. And Mars exploration. So obviously, if you want to find out any information about any planet, not just the Earth, whether it's the moon, whether it's moons, whether it's the moons of Saturn, moons of Jupiter, whether it's other planets, exoplanets beyond the solar system, right? It's important to know what the planet is made up of. And that's a very important, that's the primary task of geologists and earth scientists and earth and space scientists who do this work, right? So this colorful hodgepodge of stuff that you see on this in this image is a geological map of Mars that geologists have been able to create. They're able to tell, okay, in the blue regions, this particular rock is found. The green regions, this rock is found. And by doing that, we can tell where is potentially places where we can find maybe signs of past life, if life ever existed on Mars. Where are places where we can possibly find fossils of those life forms? Or if we want to build a base on Mars, build scientific research facilities on Mars, where is proper ground? Where you have good stable ground where you can build those facilities, right? And so far, I'm going to say remote sensing again because I love remote sensing. Remote sensing has been what they've used to they've had orbiters that go around the planet that take images of the landscape and create these maps, and then they have rovers that actually go to these places and take rock samples, and give the cameras on the rovers are able to give scientists a view of what exactly exists in those places, right? So obviously planetary exploration is a big thing that most geologists and like geoscientists, earth scientists, space scientists, all of us are excited about. All the applications of the things that we do on Earth onto planets and worlds beyond our own. Another very crucial thing that and where all the unfortunately all the money is energy exploration, right? Whether it's fossil fuels, finding out where more coal and petroleum exists, because the unfortunate truth is the world still depends on those things, and even if they are even if they are very bad for the environment and bad for life on Earth, it's something that the world's industry still depend upon. And until we're able to shift to more renewable sources of energy, we still depend upon these non-renewable sources of energy. So finding out where petroleum exists, where coal exists, these are all energy exploration aspects of geology. And then there's also conservation of species, right? So one part of the research that I am doing with leaf fossils is we're tracking how an ecosystem is changing through time, through different climate zones, how the ecosystem is changing through a sort of global warming that happened during that period of time that we're studying. And by studying how different plant species and all the animal species that are dependent on these plant species are affected by these climatic events, right? We're able to detect patterns. And so we can predict what life forms will be most affected by climate change that is currently happening. So that's a very important way in which paleontology especially is extremely important for the modern world problems that we are facing. And then there's obviously remote sensing. The more things are becoming automated, the more we have self-driving cars, for example, the more we become dependent on GPS for finding our way to places, right? We need satellites in the atmosphere. We have tons of satellites already. We need more to detect the ground surface, to detect the roads, detect buildings, and build maps and detailed maps and in visual systems that we can use to find out information, right? And it's not just about building these maps for these things. We can also use these maps to track climate. We can use these maps to track how urbanization is affecting the landscape. We can use these maps to track things like what is the health of the forests in the Amazon. Obviously, we can't go into the Amazon and count each tree and see which tree is healthy, which tree is unhealthy, right? But we can have satellite. We can do this through satellite images. We can do this through remote sensing, and do this through so many other ways where we can't be in person. And then there's obviously agriculture, where more population, more mouths to feed, more need for agriculture. So how to do agriculture sustainably so that we're not depleting the soil of its resources, depleting the soil of its nutrients. What are good agricultural practices that are able to sustain agriculture in the long run? These are all very important work that needs to be done, that is going to be done, and where jobs currently exist, right? Where exciting work opportunities exist. And so with that, we come to the end of this, what I had to say so far. And I want to open up the floor to questions, and I want to answer questions and hopefully give some more insight about what people want to know about what I do, what my degree is like, and basically, if they have any questions about any of the things that I've said, I'm more than happy to explain more about the pictures that I've displayed so far. They all have interesting stories. I've picked most of these pictures from my own camera roll. And yeah, so here's a list of topics if you find it difficult to frame a question of your own. But yeah, feel free to ask questions.
Thank you for that insightful presentation, ma'am. We will now take up questions from the audience. I request the students to address their questions to the Q&A handle on chat. We will start by looking at some of the questions shared by the students earlier on. Do you think India has a good scope for the research of Earth and space sciences? Or do we have a long way to go yet?
There is a good scope for it, yes, but there is definitely a long way that needs that has, because ISRO does a lot of excellent work when it comes to remote sensing. A lot of satellites, a lot of Earth science in space, especially, is done by ISRO. And exciting things like ISRO sent out Mars orbiter mission, right? MOM, as we all know it, is circling around Mars right now. So it is currently doing a lot of work in space sciences. So that's the space science aspect of it. Unfortunately, unlike let's say like countries in the West, right, where they have private organizations like SpaceX and Boeing that are planning to do stuff in space, India doesn't really have much private organizations currently that do space research where you can find opportunities elsewhere apart from just the government sector. But the government sector is definitely doing a lot of important stuff. And then when it comes to earth sciences, we all know India's problems with climate, right? Like every monsoon, we hear about floods, we hear about landslides, we hear about dams breaking, we hear about, I don't know, my sister told me recently there was a earthquake in Bangalore, that like a mysterious earthquake. We all like, as long as there is ground that we stand on, there's going to be geology that needs to be done, right? There's earth science work that needs to be done. And think about like before you build a building, right? Before you build a house, let's say, you want to know that the house is built on good solid ground, or else within a few years, like if there's a heavy rain or something, if the rock that it's built on is not strong enough, it's going to crack, and the building's not going to be stable long enough. So there's civil engineering aspects of geology as well. And let's not forget that India, like the northern part of India, is actually an earthquake zone. So where the Himalayas are currently continuing to grow, right? That's basically a tectonic plate that's going under another tectonic plate. And so a lot of earthquakes there. So that's another important application where geology work needs to be done. But definitely the pathway towards getting those jobs, getting those opportunities is not as easy as, let's say, like doing a computer science engineering degree or something like that, where it's opportunities and information about it is everywhere.
Thank you for that answer, ma'am. Now hand it over to our Q&A moderator for the rest of the questions.
Thank you, Bhumika. Good afternoon, Ms. Anjali. The first question we have is from Sakshi. What is the study path one would need to take to get into the field of geology and space sciences?
Yeah. So there are different things depending on what your long-term goal is, right? So I know my long-term goal is I want to get into teaching at the university level, and that requires you to have a PhD. But there's so many things you can do with just a bachelor's degree. And my personal path, which is the only thing that I can comment on, right? There are multiple ways to go about getting a geology degree and becoming an earth scientist or a geologist or geoscientist, whatever you want to call it, right? But my personal path was I did ICSE 9th till 10th grade. I did 11th and 12th grade in state board and in CMR. And I did the science pathway, PCMB, because I chose biology because I love biology, not because of anything else. But because I'm doing a bachelor's of science degree in the US, the process is a little more free here. I didn't need to do PCMB. Like I didn't need to do a science 11th and 12th grade paths to reach here where I am. But if it's in India, then the process is definitely a little more different, right? You need to get into a science university where they're doing like Bachelor of Science degrees, and the entrance exams and application processes are a little more like different and tailored towards that. But definitely the study path, there's multiple ways to get there.
Thank you so much. We have another question from Abhijit. So he asks that as a geology person who works in the field of geology, can you predict the changes that will actually happen in the future?
Yeah, I mean, it's very, the way we are predicting that climate change is going to hit this particular point by this year. So when you read news articles that say, within the next couple of years, temperatures are going to reach this point. How do we have those models and those equations that are allowing us to predict that? It's because we are studying what has happened to the earth, to life on earth in the past over millions, billions of years. And we're able to create these equations, these patterns, trends, right? And we're able to use that trends in the same way to predict what the future is going to be like. And in a way that makes us like time travelers, right? We're able to go back and forth in time and find out what is happening to the earth, or what will happen to the earth through that. So yes, we are able to predict, not just in one way, in multiple ways. I mean, I use leaf fossils. There are others who use bones of different animals. There are others who use just shells. You can tell a lot from shells and the content of shells, shelled fossils. Sorry, my cat is jumping around. But shelled fossils through millions of years. And then you can tell a lot from rocks, from the soil. There's fossil soils, by the way, which is something that blew my mind. Not just fossil plants, there's fossil soils. But yeah, a lot of different ways in which we can get there.
All right, Ms. Anjali, because of the lack of time, we will be closing the Q&A session. Over to you, Bhumika.
Since we have arrived at the end of the session, I would like to thank Ms. Anjali Manoj for being with us today, despite the challenges for time zone, as well as fitting us in our schedule. This has been a wonderful interaction, and I know we all got an exciting glimpse into the world of Earth and space sciences. I hope you all had a lovely time today. Thank you for joining us, and stay tuned for the upcoming session on Meet the Universities.
I had a wonderful time. Thank you all for joining.